K, however, is known as Coulomb's constant. And Coulomb's constant you will get from K is Coulomb's constant. And where do you get your Coulomb constant from? You'll also get it from the formula page. I want to show you where K is. Alright, 9 times 10 to the power. Do you see that value there? Alright, that is our K. Please don't cram that number because you can make a mistake. That's why you are given a formula page or a data sheet. Please go and copy. In fact, let me tell you something here. If I were to open a question paper for you, you would notice at the bottom, if you have a question paper, go check it. At the bottom, it says copyright reserved. Alright? Copyright reserved. You know what it means? It is your right to copy. Copyright. Copyright means it is your right to copy. Alright, so copy from the formula page. Get the exact value from the formula page. Let me give you a question to do quickly. Alright, I want to try you with a question and see what you will be able to do for me. Just a simple question. A very, very simple question. Okay. A very simple question. There we go. A very simple question. Simple question. I hope it's clear enough. Let me move it up a bit because of that obstruction that I have there. Hold on guys. Let me do something before you start this question. Sorry, let me just quickly do something before you start this question. Quickly. Let me give you some keynotes before you start this question, so that you go into the question armed. F is force. Measured in what? Newtons. Now, Q is charge. Measured in coulombs. Alright, Q is charge measured in coulombs. And please note, I want to give you some conversions here quickly. 1 pico coulomb, although they would not normally give you pico, is 1 times 10 to the power negative 12 coulombs. We always convert to coulombs. 1 nanocoulombs is 1 times 10 to the power negative 9. That's what you see most of the time. Nano. Nano means na, which sounds like 9. 1 microcoulombs, it's like a mu. It's 1 times 10 to the power negative 6 coulombs. Alright? These are the things you would see most of the time. So please, let's take note of these conversion. Pico, nano, and micro. Alright. Pico, nano, and micro. Maslati, you're done with that question? Okay, remember I have grade 11s. So I'm going to be very slow. They are doing this for the first time. Okay. And then you can have 1 millicoulombs, which is 1 times 10 to the power negative 3. But the two that is mostly used are these two. So please take note. Always convert to columns. All right? Another point, I said I want to arm you before you go to that question. When using F, when using this formula, all right, ignore the signs on the charges, and I want to explain that quickly. Ignore the sign on the charges. Ignore the sign on the charges. Why are we saying you should ignore the sign? If I go back to the law, what does the law say? It says what? The magnitude. The magnitude. Remember, force is a vector quantity, right? Which has both magnitude and direction. So we are saying the magnitude, which means we don't need the plus and the minus. Already we've dealt with the plus and the minus. From the first slide, we said that like charges will do what? Repel, and unlike charges will attract. That's what the plus and the minus will do. So when you are using this formula F equals to Q1, Q2, please don't put plus or minus, just write the charges. At the end, you will now tell us whether it is attraction or repulsion. How would you know that? If you have two positive charges, then they do what? They repel. If you have two negative charges, they also repel. But positive and negative will attract. So please do not use the signs when you calculate. Are we okay? The last one, R. What is R? R is the distance. And the distance between them is actually measured in meters. Common things you would find in questions. You will be given centimeter. How do you convert centimeter? You must always convert to 1 meter. Guys, you divide by 100. They will give you millimeters. I shouldn't say, okay, it's fine. 1. 2 meters. What do? You divide by 1,000. So please don't make mistakes. These are conversions that you cannot play with. Once you play with these conversions, you're actually already getting wrong answers. All right, having written all of this down, we are going to shoot and go answer a question together. And here is your question. I hope you're okay with the notes. That's your question. All right, you have 3 minutes to get that done. You can just skip Coulomb's law. You'd learn to state that after the class. We are just going for 7.2. 7.2. All right, Lindo is giving. Lindo, force. Why are you giving me columns? Force. Force. Tereshka is giving me 10.8 Newton. Pumudzo 10.8 Newton. Thank you, Lindo. Please fix it. Fix it, fix it, fix it. .8 Newton. Everybody seems to be getting 10.8 Newton. Ah, that's nice. 10.8 Newton. All right. Good. Is there anybody who did not, if you did not get 10.8 Newton, please just signify quickly. If you did not get 10.8, please just let me know. If you did not get 10.8, please let me know. All right, everybody seems to be okay.
Sir, I got 1.2 times 10 to the power of 15.
1.2.
Yes, sir.
1.2. Who am I talking to?
No.
Nell from where?
From Johannesburg.
Oh, which school in Johannesburg?
Mondio High.
Mondio.
Yes.
Mondio High. How is Madam Naidu?
She's fine, sir.
Good. I'll tell her that you called into the class.
Okay, sir.
All right, but why are you getting that? Okay, work with me now, and every other person that is not getting the answer. We are looking for the magnitude of the electrostatic force. Okay, what's our formula? F equals to K Q1 Q2 over, did you square it now? You need to check, did you square? What is our K? Please remember what I told you. Don't write from your head. Although I know it, but just to show you, I need to go to the formula page. And what is our K? Our K is 9 times 10 to the power 9. The reason is sometimes people put negative where there is no negative. All right? So K is 9 times 10 to the power 9. What is Q1? Q1 is 6. Remember we said don't put the sign. Negative 6. What is Q2? 8 times 10 to the power negative 6 over, what is the distance between them? 0,2. I probably think you forgot to square. Now,
Yes, sir.
Is this what you did?
No, sir, I didn't put the 9 times 10 to the power of 8. 6, yeah.
Okay, so are you fine now?
But, sir, where do you get it from?
Which one? The 9?
Yes.
From your formula page. I just told you that that K is a Coulomb's constant. Can you see my screen?
Yes, sir.
All right. I'm going to the formula page for you again. Do you see that there? Coulomb's constant.
Oh,
What's
yes,
the symbol? K. Do you see the value there?
Yes, sir.
Good. That's where we get it from. Pleasure. All right. So that means we can now sort this out. 10 to the power negative 6 times 8 times 10 to the power negative 6 over 0,2 squared. Let me confirm this answer. 10,8 newtons. Now, guys, what if I had cancelled this word, magnitude? And the question now says, calculate the electrostatic force. Calculate the electrostatic force. Now, because I have removed the word magnitude, it means my answer must have both magnitude and direction. Are you getting the difference? Once I remove the word magnitude, it means I must treat it as a vector quantity. Grade 10. A vector quantity is a physical quantity that has both magnitude and direction. Now, what will be the direction? Do you see we have positive and positive? What's going to happen? they would repel. So my answer would have been repulsion. If the examiner removes the word magnitude, that will have been my answer. Are we okay? Talk to me. Are we okay? Are we okay? I need to do 2 things more for you tonight. Normally our class is at 8, but I did it early because I want you guys to sleep early too today. Grade 12, you know we're going to meet. Not today. We're going to meet at 8 and then we'll run to 10. That's the norm. Everybody okay? If you're not okay, let me know. I'm waiting for your answers. Good, thank you. Who am I speaking to there? I'm Tuduzi from Petty.
Yeah.
Lovely. Good to hear your voice. All right. Everyone okay? Beautiful stuff. Beautiful. I want to take it a step further, guys. I want to take it a step further. Please, this section now that I want to do, oh my God, it's very, very important. F equals to K Q1 Q2 over R squared. We are saying that the force is directly proportional. I want to deal with graphs quickly. Directly proportional to the square. That's a directly proportional graph there. The force is directly proportional to the square, but the force is inversely proportional to the square of the distance between them. Guys, please, when you state electrostatics Coulomb's law, please don't say between their centers. It's wrong. You cannot measure a charge. A charge is very small. You cannot measure the center of the charge. It's too small. So we just say between them. Don't use the word their centers. When you are talking about universal gravitation, then you need to say between their centers. I'll repeat. When it comes to Coulomb's law, you don't say between their centers. It is just between them. But if you are dealing with universal gravitation, you say between their centers because those objects are big. All right. Now, here is my graph. I want us to deal with something here quickly. Look at this graph number 1. I want us to deal with graph number 1. Graph number 1. Guys, can we find the gradient of this graph? Examiners like hiding things here, guys. Can we find the gradient? How do we find gradient? Change in y over change in x. What is on the y-axis? It is f over q1 q2. This is my gradient. Please watch this. F over q1 q2. If I go back to my formula, look at the original formula. F equals to K Q1 Q2 over R squared. I'm going to come here and show you something now. F equals to K Q1 Q2 over R squared. F equals to K Q1 Q2 over R squared. Can I divide both sides? Divide both sides by Q1, Q2. What am I going to have? I'm going to have F over Q. I've divided both sides now, right? K over R squared. I don't know if my mathematics is okay with you. Divide both sides by Q1, Q2. All right? This is what I mean. If I write Q1, Q2 here, and I write Q1, Q2 here, what's going to happen? That and that will divide that. Does that make sense to us? And we are left with K over R squared. What does that mean? That looks like nonsense. It is not. Now we are looking at high order interpretation of questions here. By the way, what is what is F over Q1, Q2? It is M. That means my gradient equals to what? K over R squared. Let me explain what I've just done. Here you need to drink a bit of water. An examiner can give you a question like this and then tell you to find the distance between the charges. So they give you a graph. Check what you have here, F, and what you have here, Q1, Q2. Look at what I've done. I found the gradient, which is F over Q1, Q2, and that is equal to M. And I went ahead to manipulate the original formula, which means I now said F equals to K Q1 Q2 over R squared. Divide both sides by Q1 Q2. I have F over Q1 Q2 equals to K over R squared. But this F over Q1 Q2 equals to M. Hold on. Which means if I have a graph, I can then get the gradient of the graph. K is a constant. I can calculate my R. Tell me you are okay with this manipulation. So even if an examiner throws a graph at you, you know what to do. That's the first part of the graph. You use the gradient to calculate the radius, the distance between them, because K is a constant. Guys, I need responses from you. There are questions like this. So I'm preparing you for level 7 here. I'm preparing you for level 7. Good. I'm expecting that some of you will not understand what I did. All right. And I'm going to do it again.